Before we get to conferral of degrees, I'd like to introduce Andrew Yang Guo, who will speak on behalf of our undergraduate class. Andrew hails from Scarsdale, New York. His academic advisor is Professor Hari Manoharan, and his undergraduate research has been in experimental condensed matter physics. After graduation, Andrew will pursue a PhD degree in physics in the field of quantum information at the University of Maryland in College Park. So, Andrew, would you come forward?
Thanks for the introduction, Professor Michelson. Faculty, friends, family, class of 2016, congratulations. We have survived exactly 16 years, plus or minus 1 year, in the formal education system. So for most of us, we're not done yet. We are physics majors, the few, the proud, the most likely to stay in school for longer than our parents would like. At Stanford, I am proud to say that our 20 graduating physics majors and 7 engineering physics majors are part of a tight-knit community forged by 4 years of working together on problem sets and labs into the wee hours of the night. And boy, were those some really long nights. Our sense of community, one might say, sets us apart from the computer science majors. For instance, their commencement right now, you might imagine, is probably taking a while. Later, while we are enjoying wonderful bagpipe music and tiny sandwiches, we'll probably be going through the seas. Notably, although Stanford is well known for its outstanding physics research, the number of physics majors at Stanford is far fewer than the number at our peer institutions. On average, there are nearly 3 times as many physics majors at, say, MIT or Harvard, the Stanfords of the East, or at that shadowy place across the bay where the light never touches. So I asked, why do we do physics? And why here, of all places? As a Button physicist, I feel compelled to answer this question from fundamental principles. By analogy, I will demonstrate for you, in layman's terms of course, the newest theory on the block, the Stanford model of particle physics. In the Stanford model, the professors are the Higgs bosons. Supposedly, they're super important, although why exactly is a mystery to most of us. Well, some of us. They say that our professors are brilliant enough to create their own fields and have a massive impact. But I know the real answer. They're just really, really hard to find. The graduate students, on the other hand, are nearly everywhere. They're usually off procrastinating, working at nearly the speed of light. And they usually pass through the halls like ghosts, without really interacting very much with them. So in that sense, they're the neutrinos. Finally, we undergraduates are the electrons. We are easily excitable, we bond really well, and we get up to all sorts of interesting chemistry experiments on weekends. Lastly, at most undergrad institutions, condensed matter experimentalists have observed a curious phenomenon. Once an asymptotically large number of electrons gets together, some of them conducting, while the rest interacting with special metals, usually of brass or silver, that are filled with carefully placed holes. This phenomenon physicists have termed the band structure. At Stanford, band and structure is an oxymoron. So, what was the point of this theoretical exercise? Well, by reducing the members of our department to indistinguishable particles, I actually hope to highlight how wonderfully unique our department is. Our 4 years at Stanford have been the weirdest, coolest, and most enlightening experience of my life. The weirdness comes from our wacky traditions and the organized chaos that we call a band. Coolness comes from the near infinite supply of liquid nitrogen that we use to make ice cream. And the enlightenment comes from having some of the greatest instructors in the world. People who truly care about teaching and about their students. There are many selfless teachers to whom we, the class of 2016, owe an enormous debt of gratitude. But nobody has featured more prominently in our undergrad experience than our own Rick Pan. To us, Rick Pan was more than just a lab instructor. He is a man who can rub together two lead solder joints and turn them into gold. In our lab courses, he is the class clown and our grumpy father figure, not just because of his age. For him, I've prepared a short paean. Dear Rick, you brought all the charm with your flavorful joking, and you kept us from harm with your lab expertise. You helped shield our circuits from magically smoking, and funded our research with all the monies. Sincerely yours, the class of 2016.